Hello, 7th graders. Today we are going to be looking at graphing and translating inequalities. The definition of an inequality is a mathematical statement in which two expressions are not equal. So we use different symbols to express these. We use less than, which looks like this symbol here. Less than or equal to, that looks like the less than symbol but with a little line underneath it. Greater than opens up to the left, and greater than or equal to also has that line underneath it. You also might see a few different words that use the same symbol. Less than and fewer than have the same symbol. At most, maximum, or no more than, or does not exceed, has the same symbol as less than or equal to. More than or exceeds has the same symbol as greater than, and at least, minimum, or no less than has the same symbol as greater than or equal to. One thing that we always need to remember when we're dealing with inequalities is that we need to read from left to right. So we're going to write in words what the given inequality says. This first one here has that greater than or equal to sign. So we read that as x is greater than or equal to 9. For number 2, we have that less than sign. So we're going to read that as negative 6 is less than y. Go ahead and pause the video and try this last one on your own. Come back and see how you did. For number 3, we have the greater than sign. So we're going to write it as negative 7 is greater than m. So one thing for us to reflect on with inequalities is this question right here. It says, do these statements say the same thing? Here we have 5 is less than x. And here we have x is greater than 5. Well, if we were to graph this on a number line, 5 is less than x. Well, here's 0. Here's 5. X has to be somewhere to the right of 5 since it's greater than 5. Well, if we looked at this one, it's saying the same thing. X is greater than 5, and we see that on the number line because x is to the right of 5. So we always write our inequality with a variable on the left. So we wouldn't want to write it like this. We'd actually flip it around so it looks like this. Now what that means is if the inequality symbol is opening up to the x, we still have to keep it opening up to the x when we flip it so that the variable is on the left. So when we're graphing inequalities, we see those symbols that we talked about earlier. We have the less than or greater than symbol, and if we see those, we're going to have an open circle. If we have that less than or equal to or greater than or equal to with that little line below, then we're going to use a closed circle at the value. So to do this, we have steps. First, we're going to make a number line with at least 3 numbers. Second, we'll draw the correct circle above the value using these rules. And third, we'll draw a line segment to the designated area where the inequality is true. Let's look at a couple examples. So for number 1, we have y is less than or equal to negative 7. So the first step is to write my values on a number line, or write my numbers on a number line. So I'm going to put negative 7 in the middle, the value that I see, 1 below it, negative 8, and 1 higher than it, negative 6. And so now the second step is to decide should it be an open circle or a closed circle. Well, since it has that little line below it, it's less than or equal to, I'm going to put a closed circle at 7, or at negative 7. That closed circle is saying that it could be 7, or negative 7. Y could be negative 7, but we also need to draw an arrow showing that it could be anything less than negative 7 or 7 itself. Number 2 says 9 is less than x. So the first thing we're going to do is write our numbers on our number line. So I have 9 in the middle. I have 1 smaller, that's supposed to be an 8, and 1 larger, that's supposed to be a 10. So now I need to decide, am I going to have an open or a closed circle? Well, since it's just less than, I'm actually going to have an open circle at that value. Now, to figure out if it should be, if we should have an arrow pointing to the left or to the right, I'm actually going to rewrite this so that my variables on the left. Well, now that my variable is on the left, I need to show that x is greater than 9 because this means the same thing as 9 is less than x, but we want to rewrite it so our variable's on the left like we said previously. Well, now we're thinking x is anything greater than 9. So that means that we're going to point that arrow to the right, to the numbers that are greater than 9. And since it's an open circle, this time it actually can't include 9. Go ahead and pause the video and try number 3 and 4 on your own, and then come back and see how you did. All right, here we have number 3 and 4. Number 3 says m is greater than negative 4.5. So of course, since we only have that greater than and not greater than equal to sign, it's not including that negative 4.5. So we have an open circle. Now we're saying m is anything greater than negative 4.5. So we show the arrow going to the right. Number 4, we have negative 1 is greater than or equal to n, so we rewrite it with that variable on the left, saying n is less than or equal to negative 1. So, since it's less than or equal to, we draw a closed circle at negative 1, showing that negative 1 is included, and then we show that anything also less than that negative 1 can also be about what n is. So we draw an arrow to the left. So now we're actually going to work backwards. If we're given a graph, we're going to write the inequality from the graph. So of course we need a variable. I have my x, and now we need to decide which inequality symbol. Well, I'm seeing that it's anything to the left of 16, or negative 16, so anything less than negative 16. It also has that closed circle. Well, since it has that closed circle, it's anything less than or equal to negative 16. Number 2, we write our variable, and now we're looking and we see it's anything greater than that negative 2.5. So we write our greater than symbol, and since it's an open circle, it does not include that negative 2.5, so we just say that x is greater than negative 2.5. Go ahead and pause the video, try number 3 and 4 on your own, and come back and see how you did. All right, so number 3, we see that closed circle and it's pointing to the right. So we can know that x is greater than or equal to negative 18. That dot is right on that negative 18. For number 4, we have to think, okay, well, what's between 14 and 14.2 since it's not actually labeled? And we know that's 14.1. Well, now we have that open circle telling us that it's going to be x is just less than 14.1 because it's everything pointed to the left. The last thing we're going to do is translate the verbal inequalities into an algebraic expression. So for number 1, it tells us that a number is at least 15. Well, we need to think, what does at least mean? It means anything greater than, oops, I wrote less than, greater than or equal to. So our number x is anything greater than or equal to 15. Number 2 says a number is no more than negative 3. Well, if it's no more than, it's everything less than or equal to negative 3. So our number being x is less than or equal to negative 3. Number 3 says the difference of 2 and a number is at most 6. Well, the difference means we're subtracting 2 and a number, x, is at most. Well, if it's at most, it means the same thing as no more than. So it once again be less than or equal to 6. Go ahead and try these last 2 on your own. Pause the video and then come back and see how you did. All right, number 4 says the quotient of a number m4 exceeds negative 21. Well, quotient means that we're going to divide our number m4. So, oops. So we have x divided by 4, and it's going to exceed negative 21. That means it has to be greater than negative 21. The last one, 5, says 8 less than a number is no less than 1. 8 less than a number, that means we're taking 8 away from a number, x minus 8, and if it's no less than, it has to be greater than 1.